The Wrinkle Method approach is just a fast, easy, simple way to calculate out IV dosage calculations for critical care drugs. But you say, we have smart IV pumps that do the calculations for us. Why would we need to know how to do this? Well, there's several reasons. One, those IV pumps are only as good as the data that you put in. So maybe by accident you put in pounds instead of kilograms. Or what if you're working at a facility that doesn't have smart IV pumps? Better yet, wouldn't you like to be empowered to be able to do your calculations without being dependent on those smart IV pumps or having to refer to crib notes that you're carrying around with you? So, how to calculate IV medications like heparin, dopamine, insulin, Lasix, and more without using dimensional analysis? Let's talk about the Wrinkle Method. It's a group of easy-to-remember formulas. It has only 3 easy steps, and it is very bedside friendly when calculating out flow rate, titrating dosages, and rechecking for dosage rate accuracy. Doctors' orders for critical care IV infusion medications are written as dosage rates. For example, you may see heparin 18 units per hour, or it could be heparin 18 units per kilogram per hour. Dopamine, a very common drug, is written in mics per kilogram per minute, and then there's nitro, 16 mics per minute. Dosage rates are written in one of these formats below, and you'll notice that some are in minutes and some are in hours. So an example to solve dopamine 10 mics per kilogram a minute using the Wrinkle Method formula, we'll use 3 steps. First convert, then calculate a flow rate. So the problem is that we have to infuse dopamine at 10 mics per kilogram per minute, and we have 400 milligrams in 250 milliliters. The patient's weight is in kilograms, and we need to solve for a flow rate. So the first thing we're going to do is to convert. We need to convert milligrams to mics because the order is written in mics. So we're going to take 400 milligrams times 1,000 equals 400,000 mics. We now have dopamine of 4,000 mics in 250 milliliters. The patient's weight is already in kilograms, so we do not have to do any conversion there. The second is we're going to calculate a bedside value. And a bedside value is just a mathematical constant that's very specific to the drug concentration mix and the patient weight. The formula for mics per kilogram per minute is mics divided by milliliters divided by 60 minutes divided by kilograms equals a bedside value. So we're just going to plug in our values that we have. We have 400,000 mics divided by 250 milliliters divided by 60 minutes divided by 65 kilograms gives you a bedside value of 0.41. And we're going to use that number to calculate out our flow rate. We're going to use this formula right here, order over bedside value will equal a flow rate. So we're going to plug in our order, which is 10 mics. We're going to divide it by our bedside value, 0.14 equals 24 milliliters per hour. So we need to check that flow rate for dosage rate accuracy. So we're going to take milliliters per hour divided by the bedside value, multiplied by the bedside value equals the dosage rate. So we're going to take 24 milliliters per hour times 0.4 bedside value equals 9.8 mics per kilogram per minute. Of course, if you rounded that up, it would equal 10 mics. Another example would be the order is for heparin at 1,300 units per hour. We have heparin 20,000 units in 500 milliliters, and we need to solve for the flow rate. So the first thing we're going to do is convert, but there's no conversion required because the order is in units and our drug concentration is already in units. So we have 20,000 units in 500 milliliters. To calculate the bedside value, the formula for units per hour is units divided by milliliters equals a bedside value. So we have 20,000 units divided by 500 milliliters equals a bedside value of 40. Calculate the flow rate. We're going to take the order over bedside value, we're going to plug in our numbers. So 1,300 units divided by a 40 bedside value gives you a 33 milliliters per hour flow rate. We're going to check that dosage rate for accuracy. We're going to use milliliters per hour times bedside value will equal a dosage rate. So the pump is running at 33 milliliters per hour. We're going to multiply it times 40, our bedside value, and it's going to give us a dosage rate of 1,320 units per hour. What's nice about this being able to check for dosage rate is when you take over patient care and they have an order for certain medication to run at a certain dosage rate, you can take what the IV pump's flow rate is, multiply it times the bedside value, and you'll know if the dosage rate is right or not. So I hope that this video has been very helpful for you. There's a link below to get my book for all the formulas and for lots of practice problems. And thank you again for watching this video. Please check the like button